I welcome you to the part 2 section of simplifying basic trigonometric identities. Let's have a look at these various examples. Now over here we have cot raised to the power 4 theta equal to cot square theta cosec square theta minus cot square theta. So in this case, you can see that the right hand side of this identity is complex. So we need to deduce the right hand side to be equal to what we have at the left hand side. So we are going to take the right hand side and work with so that it will be equal to what we have at the left hand side. So we have here to be cot square theta cosec square theta minus cot square theta. So we can see we have two terms in this expression. Cot square theta is found in both of the terms that we have here. So we are going to take the common factor out of this expression, that is cot square theta. So we write the remaining in the brackets. So at this side it is left with cosec square theta, and this cos square theta is already been taken out, so we have the remaining to be 1. This gives us a particular identity that says 1 plus cot square theta is equal to cosec square theta. So if you want to get cosec square theta minus 1, we need to take this 1 to join the cosec square theta, so that we are going to get cot square theta equal to cosec square theta minus 1. So this expression in the bracket is equal to cot square theta. So you are going to multiply it with cot square theta at this side, and when they multiply we are going to add the exponent, that will be cot to the power 4 theta, and this gives us the identity at the left hand side. Let's look at another example. So we have the second one. We have this identity. What we have at the left hand side is more complex than what we have at the right hand side. So we are going to also take the left hand side identity and solve. We have 1 plus cos theta over sine theta plus sine theta over 1 plus cos theta. In this state, we are going to find our common LCM. That is sine theta times 1 plus cos theta. Then find what we have here for the numerator. So sine theta will cancel the sine theta, leaving 1 plus cos theta. That will multiply the numerator of the sine theta. That will give you 1 plus cos theta squared. Then we have 1 plus cos theta will cancel 1 plus cos theta as the denominator here, leaving sine theta, multiplying the numerator of 1 plus cos theta, which is also sine theta. That will give you sine square theta. So we are going to expand the brackets found at the numerator here. So we are going to have 1 plus 2 cos theta plus cos square theta, then plus sine square theta for this one, all over sine theta multiplied by 1 plus cos theta. Now we have cos square theta plus sine square theta, which also form an identity to be 1. So I'm going to replace this identity here and write 1, and we have another one here which will add up to be 2. So we have 2 plus 2 cos theta all over sine theta multiplied by 1 plus cos theta. Then we also need to take 2 out here as our common factor. Then we continue. So over here I have 2 being taken out, so it is left with 1 plus cos theta all over sine theta multiplied by 1 plus cos theta. So we have a common identity here which we need to cancel. Then we have left with 2 multiplied by 1 over sine theta. And we know 1 over sine theta will give you cosec theta. So that is, we have 2 cosec theta. And that gives you the same identity which is at the right hand side. Let's have a look at more examples here. So we have cot pi over 2 minus theta multiplied by cot theta, and said you should prove it to be equal to 1. And this identity here referring to this cot is equal to tan theta. So we are going to replace everything here by tan theta. So tan theta multiplied by cot theta. We know cot theta is 1 over tan theta, so we are going to replace cot theta by 1 over tan theta. Then we divide this by 1. So when we cancel out, we are going to get 1. So the answer is 1, which has been proven. The same identity. The last example, we have odd and even function that says sine negative theta is equal to negative sine theta, cos negative theta is cos positive theta. So over here, we are going to use this function, odd and even function, to solve this problem. So if we have sine negative theta, it is still the same as negative into bracket sine negative sine theta all over. Then this one too, we have negative into bracket positive cos theta. All right. Now when we multiply these operations, negative times negative will give you positive. So I'm going to get positive sine theta here, and negative times positive will give you negative. That will give you negative cos theta. Now in this case, sine theta over cos theta will give you tan theta, but it is negative. So we are going to get our final answer to be negative tan theta, and our identity is solved. These are many more examples that we can get under trigonometric identities. Please don't forget to like and subscribe to my channel. Thank you for watching.